Chapter 5 Refraction Part 3 Lenses. Look at a wire glass. The wire glass can form two different images. For the image on the top, it is diminished and erect. And this part of the wire glass refracts light as a concave lens. For the lower part, the image is diminished and inverted, and this part of the wire glass reflects light as a convex lens. So you see that different lenses may form images of different natures. In fact, the upper image is erect and virtual, and the lower image is inverted and real. Some images are magnified while some are diminished. It is interesting to know that all images, if they are erect, they must be virtual. If they are inverted, then they must be real. So in the coming lesson, you are going to do an experiment to find out the natures of image formed by different lenses when the object is placed at different distances. To prepare for the experiment, you have to learn some basics about lenses. First, lenses are classified into two types: converging lens and divergent lens. Convex lens is a kind of convergent lens which converts light. When there is parallel light rays that strike on the lens symmetrically, then these light rays will come to a principal focus. We say that the light rays are converged to the focus. Similarly, for concave lens, when parallel light rays strike the lens symmetrically, the light rays will be diverged from the focus. This is not too difficult to understand why parallel light rays are converged by a converging lens and diverged by a divergent lens. Let's look at this corner of the lens. There is a prism, and if you look at the prism and look at how the light ray may go through the prism, you will know, whoops, the light ray will go in this way. It will be reflected towards the base, and no wonder the two light rays from the two sides will be converged to the focus. Similarly, let's look at a divergent lens. Again, let's look at this corner. There is a inverted prism, and when the light ray is reflected, and of course it will be reflected towards the base again. And so, for the light ray on the other side, similarly reflected, and so the two reflected light rays, or even say all of the reflected light rays, will appear to come from a single point, which we call it focus. Among the two, convex lenses form more complicated images. It forms very different images that depends on the object distance. For example, for the diagram on the left, that convex lens forms an image which is magnified, erect, and virtual. For the image on the right, on the other hand, it is diminished, inverted, and real. Even though both are convex lenses, but they form different images because they have different object distances. On the other hand, for concave lens, the image is always erect, virtual, and diminished. For example, look at the diagram below. The image here is diminished, erect, and because it is erect, it must be virtual. You will learn to draw ray diagrams for lenses very soon. To do so, you must, first of all, remember construction rules. There are 3 construction rules for both convex lens and concave lens. First of all, let me introduce the last one. When a light ray passes through the very center of a lens, whether it is concave or convex, it will just go straight. Second, let's go to ray number 1. When the light ray goes this way, parallel to the principal axis, it will be refracted to pass through the focus on the other side. This is for convex lens. Similarly, for concave lens, when the light ray goes parallel to the principal axis, it will be refracted along this direction so that the reflected ray appears to come from a point on the principal axis, which is the focus. So for the last one is ray 2. A light ray that goes through the focus straight on the lens, it will be reflected parallel to the principal axis for the convex lens. Similarly, for the concave lens, when a light ray aims at the focus on the other side of the lens, then it would be refracted parallel to the principal axis direction. So spend some time to memorize all these 6 light rays. Now let's draw the construction rules again in these 2 diagrams. First of all, for the light ray that passes through the very center of the lens, it should go straight. Next, when a light ray parallel to the principal axis strikes a convex lens, it will be refracted, passing through the focus on the other side. For the concave lens, on the other hand, it will be refracted in this way, so that it appears to come from the focus. For the last one, when a light ray passes through the focus, strike a convex lens, it will be refracted in a direction parallel to the principal axis for the convex lens. And what about for concave lens? The light ray that aims at the focus on the other side would be refracted parallel to the principal axis, so that it appears to come from this direction. And now I draw an observer eye for the convex lens. For the observer, he may believe that the refracted light ray comes from this point, and so the image of the object should look like this, which is inverted. Similarly, for a concave lens, the refracted light rays A, B, C, they all appear to come from this point. So the whole image is formed here, and the image is erect, diminished, and virtual. You can see in both cases, the 3 light rays will eventually meet at a point. They intersect at the same point where the image is, and in this way form an image. So next time when you draw a ray diagram for concave lens or convex lens, you may draw any 2 out of the 3 construction rules in order to locate the image.